Good evening, children. We were doing curve sketching, right? Using differentiation. I'm not quite sure whether we were at the same, we stopped at the same place in both the classes. There can be some difference, but Thursday class, we were discussing how to identify a stationary point, right? The type of a stationary point. Mainly two things we learned. We are trying to describe the shape of the curve using the differential coefficient. Considering graph of a function y plus fx, we find the derivative. Then at some point, x naught, y naught, this gives the gradient of the curve. Then we said if this dy by dx, the differential coefficient is positive, the curve can pass the point either this way or this way. Curve is increasing. If dy by dx is positive at some point, the curve is increasing at that point, can be either rapidly increasing, concaved up, or slowly increasing, concaved down. If dy by dx at a particular point is less than 0, the curve passing the point can be either concaved down, decreasing, concaved down, shaped like this, or it can be again decreasing but concaved up. These are the possibilities. The curve is anyway decreasing. It can happen two ways, concave down or concave up, right? Then we discussed the case where dy by dx is at a particular point is equal to 0. equal to 0, we said there's a stationary point. This x0, y0 is a stationary point. There are several possibilities. Except for the constant function, there are several possibilities. This is one possibility. There can be a local minimum at that point, or it can be another possibility is local maximum at that point, or even it can be an increasing inflection at the point x0, y0, or it can also be a decreasing inflection. Like this, right? First, we identify if there is a stationary point to the curve using this. If at x0, y0, dy by dx is equal to 0, there is a stationary point. x0, y0 is a stationary point. Then to identify the type of the stationary point, right? Whether it is this or that or the other one, right? Out of these four, which type of a stationary point it is, right? To identify the type, we have two tests, right? Two tests. The first is the first derivative test. The second is the second derivative test. So last day we discussed the first derivative test, right? We first finish all these, draw the graphs, discuss everything, and draw the graphs also. And after that, we can come to. I'll teach you the second derivative test, right? For the moment, we don't need it, right? We can draw the graph without the second derivative test, right? The first derivative test is this, but we learned last day. We constructed a table. Sin of dy by dx, dy by dx, then the stationary point. At x equals x naught, at x equals x naught minus delta x, at x equals x naught plus delta x, right? We check the sign of dy by dx at x equals x naught, it has to be 0. Only if it's 0, we further investigate, right? Then a little left to that, it is negative, positive, then little right to that, say it is negative, then we know that it's the local maximum, right? Local maximum. If negative and positive, it's the local minimum. Positive and positive, it's an increasing inflection. Negative and negative, it's a decreasing inflection, right? And we did some examples for this also, and this is where we stopped in the Thursday class. Now I remember in the Sunday class we discussed about asymptotes also. Yeah. We first see the answers for some the homework questions I gave, then we can come to asymptotes. After that, today we can start drawing graphs, right? So the homework questions I gave, I don't think that I have to work out all these. There are 9 questions. I don't think I have to work out all these and show the answer. I'll do 3, 4 of them. That'll be enough. For you to check your answers. This is the third I have given for homework. The Thursday class. Sunday class එකයි චුට්ටක් බලාගෙන ඉන්න. ඔයගොල්ලන්ට මේ examples කරා. asymptotes පොඩ්ඩක් විස්තර කරා. පොඩ්ඩක් ඔයගොල්ලෝ බලාගෙන ඉන්නකෝ ආයිසර. right. කට්ටියගේ නම් දැක්කෙත් නෑ මම. නම් බලමු කවුද ඉන්නේ ක්ලාස් එකේ. නම් දාන්නකෝ බලන්න ඉන්න අයගේ බලන්න. මෙසේජ් එක හැමෝටම හම්බෙන්නේ නැති නේද? ලිනාලා එන කවුද? කවිෂා ඉස්මාල් කුසල්නි සිතුම්යා හරි සන්ඩේ ක්ලාස් එකේ කට්ටියක් ඉන්නවනේ නේද? අභීත හරි කට්ටිය දන්නවනේ අලුතෙන් ආපු ළමයි කොහමද නේ හරි අපි කරගෙන යමු ළමයි මොන කරනද we had to retreat back to home again we'll wait and see for a week or two දැන්ට පේන විදිහට නම් කලින් වගේ ලොකු වර්ධයක් එන එකක් නෑ වගේ අපි උන් දවස් දෙකක් බලමු තව right බලලා ලොකු ප්‍රශ්නයක් නැත්නම් අපි පොදු විදියට බන්දේ පටන් ගමු. දැන්ට මෙහෙම කරගෙන යන්න. දවස් දෙකක් බලමුකෝ සතියක් දෙකක් විතර. පේන විදියට ලොකු අවුලක් වෙන එකකුත් නෑ වගේ. හරි අපි මේ කරගෙන මේ graph අපිට ඉවර කරන්න පුළුවන් දවස් දෙකකින් කොහොමද? Okay, this is the third question I gave, x cubed minus 2x squared minus 4x plus 8. You first find dy by dx. It is 3x squared minus 4x minus 4. You have factors minus 2 plus 2. So in the real number line, you mark everything minus 203 plus 2. dy by dx is equal to 0 at these points. And on either side greater than 0. In the middle less than 0. So it changes from positive to negative. Positive to negative, that means going up and then starts coming down. Then this one negative to positive. So at minus 203 it's the local maximum. At 2 it's local minimum. May y values local thing. Y values දාගන්න මම නිකන් කෙටියෙන් ලියන්න. This is a local maximum, right? A local maximum give the point. You have to give the answer minus 203 and y value also is the local maximum. Then when x is 2, y will be y will be 0. 2 and 0, a local minimum. Sorry. 203 mathematical minus 5 or 27 or something. 27 right? This one is a local maximum. This one is a local minimum. I'll go to question number 5 then. Y equals x cube minus 3x square plus 3x minus 1. And dy by dx is 3x squared minus 6x plus 3. You take 3 out. X square minus 2x plus 1. So it is 3 times x minus 1 square. It's a perfect square. So you mark 1. At 1 dy by dx is equal to 0. Right of 1 and it's a square. The left of 1 or right of 1, it is positive. So it changes from positive to positive. No change. In fact, it's then an increasing in section, right? This is the first derivative test we are learning, right? There is another test called the second derivative test. This is the first derivative test. Okay, first derivative test. So it gives 1 0. It's an increasing inflection. Okay, that's question number 4. This is 3. We can get number 6. Y equals x square minus 1 square. So dy by dx is 2x times x square minus 1. No, 4x times x square minus 1. Make a factors 4x, x minus 1, x plus 1. You in the real number line you mark minus 1, 0 and 1. At these points dy by dx is equal to 0. Dy by dx is equal to 0. Dy by dx is equal to 0. Here it is positive. Dy by dx is positive. Then negative. Again dy by dx is positive. And finally negative. So at minus 1 it changes from minus to plus. Minus to plus. A local minimum. Here it is plus to minus. A local maximum. This one minus to plus again. A local minimum. Right? Minus 1 0. Minus 1 0 is the local maximum. Local minimum. 1 0 0 0 0 1. 0 1 is the local. This one is the local maximum. So again at 1 0 1 0 local minimum. Right. Number 7. ඔගොල්ලෝ හරි වැරදි බලාගෙන විතරයි මම මේ කරගෙන යන්නේ. පාඩම මේ ගෙන්වන්නේ කිව්සතියේ y equal 2x over x squared plus 4 ද තමයි මම දුන්නේ. මෙතන plus 1 තිබුණා නම් තමයි හොඳ. plus 4 තිබුණා නම් මේක අමාරුයි නේ. මම plus 1 කියලා කරන්නද? පොඩ්ඩක් බලමු. මොනවද ලක්ෂණ උත්තරේ ඉන්නේ? x square plus 1 squared x square plus 1 into 1 minus x into 2x. Oh. plus 1 තිබුණා නම් තමයි හොඳ. කමන්නේ plus 4 තියලා හදමු. plus 4 තිබුණොත් වෙන්නේ එතකොට ඔහොම එන්නේ නේ. x square plus 4 into 1 minus එහෙමනම් එන්නේ මෙතන 4 minus x squared කියලාද? 2x squared x squared 4 minus x squared නේ. හරි. අවුලක් නැහැ. x squared plus 4 squared. So then better we take minus 1 out. Then you get x square minus 4 can be written as x minus 2 into x plus 2 over x square plus 4 square. How many in? Now go to the real number line. So you mark minus 2 and plus 2 at these points. dy by dx is equal to 0. Equal to 0 and then the sign here. Usually it's positive. Usually it's positive here. But look at that. There is a minus 1 outside. Therefore it will turn to the opposite side. Right? So you take the opposite sign. So dy by dx is less than 0. Here usually negative, but with this minus it turns plus. Here usually positive, with this minus it turns minus. So මෙහෙමයි එන්නේ minus 2 plus it's the local minimum, plus to minus the local maximum. හරිනේ? මොකද net minus 2 minus 4. Therefore minus 2 minus 2 and half. Minus 2 and minus half. At minus 2 minus half, a local minimum. Then 2 and plus half. A local maximum. හරි. ඔය ටික අඩුපාඩු හදාගන්නකො. මම විනාඩි කිහිපයක් දෙන්නම්. අඩුපාඩු හදාගන්න ළමයි. ඊට පස්සේ තව එකක් දෙකක් තියෙනවා. මේ ටික බලලා අපි asymptotes වලට යමු. ඕකා එක කියලා දෙනවා මම හිතන්නේ මම මේ ටික කරත් ඇති නේද ඔයගොල්ලන්ට මේ අදහසක් ගන්න. හරි වැරදි බලාගන්න. ඒකත් ක්ලාස් එකේ එක්සැම්පල්ස් දෙකක් කරලා තිබුණානේ. මේ තුනත් ඇති නේද? එතන හතරක් කරලා තින්නේ. 1 2 3. කරපු දේ තේරුම් ගන්නවා ඇති නේද? graph හඳිනකොට ආයි මේ බලමු. So we can go to the next topic. Okay, shall we go to the next topic? Then we discuss asymptotes, but in fact everything about asymptotes we have done earlier under limits, right? In limits I have given these things as the behavior of a function close to asymptotes. Now we have to only to give it formally, right, systematically, without much explanations. We have done it earlier, right? Now just to collect it again. Asymptotes. Asymptotes. Sometimes we see, not always. Some graphs get parallel to some straight lines. There are sometimes the curves get parallel to straight lines, right? If such a straight line like this, we call an asymptote of this graph, right? Looks like this. If a curve gets parallel, if a curve of y equals fx gets parallel to a straight line, this straight line we call an asymptote. Right? Sometimes we see the graph gets parallel to a straight line. Such a straight line is called an asymptote. Here, an asymptote of the curve, right? There can be asymptotes in any direction, right? But here in this syllabus, we consider only two types of asymptotes, right? We want to discuss only horizontal asymptotes, which are parallel to x-axis, and vertical asymptotes, which are parallel to y-axis. Only those two we here do in the A-level syllabus, right? In our syllabus. Uh, First, horizontal asymptotes. So what are horizontal asymptote? Horizontal means an asymptote if it is parallel to x-axis, right? That's the standard, right? We say it's parallel to x-axis. We say it's a horizontal asymptote. It looks like this. If you have a line, say passes C, so there will be y equals C, a straight line like this, to which the curve gets parallel, like this, or maybe from below, as it's, if the curve gets parallel to some straight line, say x equals C or y equals C, not x equals C, y equals C, something parallel to x-axis, we call it uh, a horizontal asymptote. This is, here is a horizontal asymptote. කලින් කියලා දෙලා තියෙන නිසා මන්ට එක්මනින් කරගෙන යනවා. Only the definitions we haven't seen earlier, but examples we have seen, right? We say an asymptote which is parallel to y-axis, sorry, x-axis is called a horizontal asymptote. Horizontal asymptote, right? The thing to note is, did you notice that a horizontal asymptote exists only if x goes to infinity? For a horizontal asymptote, x should go to positive infinity or negative infinity, right? So you can check if there is a horizontal asymptote, you can find it as you send x to infinity, the limit of the function. Find the limit of the function as x goes to infinity or negative infinity. If it gets parallel to some constant value, say c, then you see that y equals c is a horizontal asymptote. අපි examples බලමු. කලින් කරලා තියෙන්නේ. ආයි කීපයක් මම මතක් කරන්න. ඒකත් තව ටිකක් තේරෙයි. Right? So we write a horizontal asymptote if any, right? Exists as x goes to plus or minus infinity, right? So welcome to vertical asymptotes also, then we can come to examples. Number 2, vertical asymptotes. Vertical asymptotes are the asymptotes which are parallel to y-axis, right? An asymptote is parallel to y-axis which is parallel to y-axis, something like this, is called a vertical asymptote. Let's see here, then the equation will look like x equals c, equation of the line, x equals c, since x value is constant everywhere, and an asymptote like this we call a vertical asymptote, right? That means the curve is getting parallel to this, so that can happen either this way or maybe this way. So anyway, a vertical asymptote exists for a vertical asymptote. Y should go to positive infinity or negative infinity, right? Make on the for a vertical asymptote, y should go to positive infinity or negative infinity. Negative infinity. Say y to go to infinity as you get closer to c from this side or that side. Did you notice that this to happen in the denominator of fx? There should be some x minus c. Maybe there are other parts also. There should be some x minus c. For a vertical asymptote at c, there should be some x minus c in the denominator. So if you have x minus c in the denominator, then as you get closer to c from this side or the other side, x minus c will get closer to 0. If you get closer to c from this side, x minus c will get closer to 0 from positive side. You get closer to 0 from this side, x minus c will get closer to 0 from negative side, right? By negative values. So that will, together with the other things, that will decide, that will make it go into infinity, positive infinity or negative infinity, right? So in short, x equals c, you get x equals c a vertical asymptote only if you have x minus c in the denominator of the function, right? An asymptote which is parallel to y-axis is called a vertical asymptote, right? We get a vertical asymptote x equals c only if x minus c is in the denominator of y. So y has some terms in the numerator, some terms in the denominator, together with x minus c. If you see x minus c in the denominator, then you get x equals c, a vertical asymptote. උතන නිකන් ලියා ගන්නකො අපි examples වලින් බලමු. මෙහෙම වචන වලින් විස්තර කරනවට නම් හොඳයි. examples වලින් බලන එක. හරි? ඔය ටික ලියා ගන්න ළමයි. Make a pain nagalame. Make a man, phenomenon. Make a pen and a hurry to balala. Like examples. Explain the behavior of y close to asymptotes in each of the following. In each of the following, right? Right, number one. මේ examples මම කලින් දීපුවා. මේ වගේම දීලා තියෙයි. දැන් මේ ආයෙ මතක් කිරීමක් කරන්නේ. මම සතිය ඉක්මනින් කරගෙන යනවා. හරි. Right, number one. This y equals 1 over x. Y equals 1 over x. So answer. You want to check for horizontal asymptotes, you have to send x to infinity, right? In this you see y, where will go to y as x goes to positive infinity. If x goes to positive infinity, in limits we have discussed these things. If x goes to positive infinity, y will go to 0. Y will go to 0, but y can go to 0 from two sides, either this or this, from above or below. But here we know that as x goes to positive infinity, x is positive. Then 1 over x has to be positive. So this should come to 0 via positive values, not from negative values. Then it has to be from positive side. Okay. Then as x goes to negative infinity, still y will go to 0. This time, as x is negative, 1 over x will also be negative. So it will come to 0 from negative side, below, not from above. Not from above, from below. So 0 from negative side. So this is the horizontal asymptote. There is a horizontal asymptote. For this graph of this, it is the x-axis. Then to check for vertical asymptotes, you have to see if the denominator equals 0 for some x. In this, yes, there is a value. When x is 0, the denominator is 0, right? So you can check as x goes to 0 from this side, what happens? X goes to 0 from positive side. X goes to 0 from positive side, 1 over x will go to infinity, but we don't know whether to positive infinity or negative infinity. We'll find it. As x goes to 0 from negative side, as x goes to 0 from negative side also, y will go to positive infinity or negative infinity. We have checked that, right? So how to find whether it is going to positive infinity or negative infinity? That depends upon close to 0. That depends upon close to 0 if y is positive or negative, right? Look at this. We are going to check for the sign of y, whether y is positive or negative in each section of the real number line. We have to consider only one factor, that is x. So whether y is positive or negative depends upon if x is right to 0 or left to 0. Only 0 you have to mark. Inequalities, right? So right of 0 you know that this y is positive. Left of 0 y is negative. So since it is y is positive right of 0, then should go to positive infinity. Since y is negative left of 0, it should go to negative infinity. right? Should go to positive infinity as x gets closer to 0 from this side. Should go like this. Again, as you get closer to 0 from negative side, y should go to negative infinity. Like this. Now, cutting another thing on this. The first example. ඊට පස්සේ මේ මම වෙලා දෙන්න මේ දෙක කරන් තනියම y plus minus 1 over x. Number 3. 1 over x squared. හරි මේක ලියාගෙන මේ ටික කරගෙන යන්න මම පොඩ්ඩක් වෙලා දෙන්න. Right, see the answer for the next. As x goes to positive infinity, x goes to positive infinity, minus 1 of x, that will be negative. So it will go to 0 from negative side, like this. So as x goes to negative infinity, x is negative, the whole thing will be positive. So y will go to 0 from positive side. Happen like this. Then again, as x goes to 0, you see that 0 from positive side, y will go to infinity, but as x is positive, 1 over, minus 1 over x will be negative. So you get closer to 0 from this side, that will go to negative infinity, right? Similarly, as x goes to 0 from negative side, x is negative, minus 1 over x will be positive, then it will go to positive infinity. This is the answer. Y will go to positive infinity as x goes to 0 from negative side. Make a balance. Here again, right? As x goes to infinity, you can check whether there is a horizontal asymptote or not. Here again, as x goes to infinity, this will go to 0. So y will go to 0 as x goes to infinity, but as x goes to infinity, x square will be positive, so it will go to 0 from positive values. Via positive values, right? Then as x goes to negative infinity, but x square is positive. X square is positive, so 1 of x square will be, it will go to 0 again, again from positive side. It's never negative. 0 plus. Go to infinity like this. So again, x-axis is horizontal asymptote. Now to check for vertical asymptotes, you see that this is 0 when x is 0. This is 0 when x is 0. As x goes to 0 from positive side. From positive side, x square is always positive. Therefore, it will go to infinity from positive side. Make a angle මේක ඇඳලා බලනවා නම් sorry ඇඳලා බලන්න ඕන තමයි මේක ලේසියෙන් සාමාන්‍ය එකක් කියලා දැන් ඒ උනාට ඇඳලා බලන්න 0 man we are checking the sign of fx y so right of 0 minus 1 of x will be negative left of that will be positive so it goes to negative infinity positive infinity. Check the sign of y around this vertical asymptote, right? Methanast එහෙම බැලුවොත් again x equals 0 is the critical point in x-axis. On either side y is positive because it's x square, right? So it has to go to the positive infinity. So I will go to positive infinity as x goes to 0 from positive side. So as x goes to 0 from negative side also, y will go to positive infinity. So මෙහෙම හරි. තව එක්සැම්පල් එකක් කරමු. මේ ටික මතක් වෙන හොඳට මතක තියාගන්න ළමයි. ලංකාවේ මොනවාද අපේ A-level combined maths paper එකේ මේ graph එක ගොඩක් ළමයින්ට අදගන්න බැරි වෙනවා. මෙන්න මේ කාරණේ නිසා. හරි. Asymptotes. They don't know how to mark the curve close to asymptotes. ඕකෙන් ගොඩාක් ළමයි වැඩේ වරද්ද ගන්නවා. හරි. ඒ නිසා මේක හරියට ඉගෙන ගන්න මම මේ දෙවෙනි සැරේට මතක් කරන්නේ. මේ asymptotes මේ ටික හොඳට තේරුම් ගත්තම graph හඳින්න පුළුවන්. හරි. A few more examples. Number 4, y equals x plus 1 over x minus 2. කරගෙන යන්නකො බලන්න. ඔය දෙකත් කරන්නකො බලන්න. මේක බලමු. If you want to check for horizontal asymptotes, you have to send x to infinity, right? What happens to y? Y as x goes to positive infinity. ඔයගොල්ලන්ට මතකනේ මම ලේසි ක්‍රමයක් කියලා දීලා තියා. වැඩි වැඩ දාන්න මොනවද උන්නේ? Just look at the two highest power terms. X and x. They get cancelled and give 1. As x goes to infinity, you have to find where goes y, limit of y. මතකනේ මම ලේසි විදියට කියලා දීලා තියා. Just look at the two highest power terms. So that will give 1. So I'll go to 1. 1 හැබැයි we know that it goes to 1 as x goes to infinity. But for the moment we don't know whether from above or below. Get close to 1 from above or below. ඒක හොයන විදියක් මම කියලා ඉතින් හොර ක්‍රමයක්, right? If you want to find whether it's coming from that means via greater values to 1 or smaller values to 1, we just substitute some big value for x. Say x equals 100, some big value for x, and check whether y is greater than 1 or less than 1 for a big value of x. X equals 100 will give 101 when x is 100, 101 over 98. 101 over 98. This is definitely greater than 1. Therefore, we conclude that when x is very large, y is greater than 1. So it's above this asymptote. Then it comes to 1 via positive that's from 1 plus positive side of 1, right? Similarly, as x goes to negative infinity, again we know that y gets closer to 1, but whether to check whether from above or below, we apply some big negative value. X is minus 100. मैं उगाना में तीन है मामे आए मदद करना है तो minus 100, that will give minus 99 over minus 102. Negative minus and minus will get cancelled. You get like 99 over 102. This time it is less than 1. So we know that y goes to 1, but as x is very big on negative side, get more and more left. Y values are less than 1. This is what we get from that. This, right? So we conclude that it goes to 1 from below the negative side. Right. Now vertical asymptote. So this is the horizontal asymptote, right? X equals 1. Rather y equals 1. This is the horizontal asymptote. Then vertical asymptote. So there is a vertical asymptote at x equals 2 because when x equals 2, this denominator is 0. Hmm? Right. So we know that y goes to positive or negative infinity as you get closer to 2 from right side. Again, y goes to positive or negative infinity as you get closer to 2 from this side. So let's see from whether it goes to positive infinity or negative infinity. It depends upon whether y is positive or negative. We want to check the sign of y close to 2. But the sign of y is not determined only by x minus 2. There's another factor, x plus 1. So you have to consider both these. You have to consider both these to check for the sign of y. Right? Now, right of 2, this whole thing is positive. In the middle, it is negative. Again, left of 1, y is positive. So, to get closer to 2 from right side, since y is positive, we will go to positive infinity. Here y is negative, it will go to negative infinity. So it will go to here, it will go to positive infinity and negative infinity. So you will write it as so y goes to positive infinity as x goes to 2 from right side. Y goes to negative infinity, y goes to negative infinity as x goes to 2 from negative side. කොහොමද වෙන්නේ? මේකත් ආයි බලන්න කොටස් හරි වෙද්දි. ඊට පස්සේ අපි graph අදින්න පටන් ගන්නවා. I give 2-3 minutes to sit down for this also. බලමුද ළමයි? Where goes y as x goes to positive infinity, right? As x goes to positive infinity, consider the highest power terms. Here x, highest power term, here x squared. It's like x over x squared when x goes to infinity, so they'll give like 1 over x. It's as same as 1 over x. As x is very large, this is as same as 1 over x, so it will go to 0. Y will go to 0, right? Then the question whether from above or below, as x is very big, whether y values are positive or negative. You can easily check. As x is very big, this will be positive, this will be positive, this will also be positive, positive, so it will be positive finally. So I will go to 0 from positive side, right? Then as x goes to negative infinity, still y will go to 0, but whether from positive side or negative side, you have to check that. As x is very big negative, this will be negative, this will also be negative, so will be this, right? So 3 negative ones, y will be negative. As x is very x goes for the left and left, all these will be negative, so y will be negative, so y will go to 0 from negative side, like this. That's the horizontal asymptote. Then the vertical asymptote. So how many vertical asymptotes are there for this? How many vertical asymptotes? You see that the denominator gets 0 for two values. X equals plus 2, x equals minus 2. That means there are two vertical asymptotes. One at minus 2, the other at plus 2. Right. Now, as x goes to 2 from right side, this will go to positive infinity or negative infinity. You get closer to 2 from negative side, it will go to positive infinity or negative infinity. Similarly, you get closer to minus 2 from right side, it will go to positive infinity or negative infinity. You get closer to minus 2 from left side, it will go to positive infinity or negative infinity, right? To find the exact direction along which it goes to infinity, you have to check for the sign of y, whether y is positive or negative in each of these sections, right? So that's the sign of y. The sign of y is determined by three factors. This send is three factors. So in the real number line, you mark minus 2, minus 1 and plus 2. Minus 2, minus 1 and plus 2. So to vertical asymptotes at minus 2 and plus 2. So far right, on far right, everything is positive, so y is positive. In this section, y is negative. In this section, again y is positive. Finally, y is negative. So you can determine y is positive here, so it will go to positive infinity. In this section, close to 2, y is negative, so it will go to negative infinity. Here again y is positive, go to positive infinity, and this side y will go to negative infinity. Positive infinity goes to negative infinity, again goes to positive infinity, and finally to negative infinity. To get closer to 2 from right side, y will go to positive infinity. To get closer to 2 from negative side, y will go to negative infinity. To get closer to minus 2 from positive side, y will go to positive infinity, right? To get closer to minus 2 from negative side, y will go to negative infinity. So that's the complete answer.